we shall be looking at the Newton's second law of motion. The Newton's second law of motion tells us that the rate of change of momentum of a body is directly proportional to the resultant external force and takes place in the direction in which the force acts. That law simply explains to us the momentum of a body, and it states that the momentum of a body is the product of the body's mass and its velocity. Mathematically, we can say that momentum is equals to mass multiplied by velocity. The SI unit for momentum is the kilogram per meter, or what we call kilogram meter per second. This is the same as the Newton second. Of course, momentum is a vector quantity and its direction corresponds with that of the velocity. Suppose a force acts on a body of a mass for some time t, at some second, and causes its velocity to change from its initial velocity u to its final velocity. What will that left us to? The way we are simply saying that the initial momentum, let's have the initial momentum, will be given by mu. We have the final momentum, which is given by mv. The change in momentum will be given then by mv minus mu. Why? Because v is the final velocity and u is the initial velocity. So the change in momentum will be given by this. Of course, with some time t, so that we have some time t. This will give us the second law of motion if we manipulate this formula. Let us see if we separate the momentum, the mass of that object, we will simply have m into v minus u divided by t. But we know that acceleration is also given by v, which is the final velocity minus the initial velocity in respect with time. So the rate of change of momentum will become ma with regard to acceleration. So force is said to be proportional to the rate of change of momentum. Therefore, we can say that F is equals to ma, because this shows the proportionality of this change. So force is directly proportional to ma. So we can say that force is equals to kma, where k is the constant of proportionality. So with this, it can now help us to derive the equation of the second equation of motion, or the second law equation, where we have F is equal to ma. If force is equals to ma, what is a Newton? What exactly is a Newton? The Newton is defined as the force which produces an acceleration of 1 meter per second squared when it acts on a mass of 1 kilogram. Using the SI unit, we can now substitute the values of that above equation, that force is equals to ma as indicated. So let me show you now how we can derive this second equation of motion in terms of force is equals to ma. Here, if we have force to be equals to 1 Newton, and we have the mass to be equals to 1 kg, it is given by 1 kg. But we also know that acceleration is given by 1 meter per second, as I mentioned earlier. per second squared. So it will give us F, which is the force, as mentioned, is kma, where k is the constant of proportionality. So if we do our inverse substitution, we will simply have 1 Newton to be equals to that constant multiplied by 1 kg multiplied by 1 meter per second squared. So K will be given by 1 Newton divided by 1 kg times 1 meter per second squared. Of course, now we can, from this equation, we know that we have our 1 Newton. We know what is 1 Newton. So we can say, but 1 Newton is equals to 1 kg. And this will left us with K to be equals to 1. Therefore, we can say that F is equals to ma. And this is how we derive this second law of motion formula, the equations of motion. So by the laws of motion, everything will make sense in our day-to-day activity. Nothing will actually move, not unless acted upon by an external force. And according to the second law, we know that the rate of change of that momentum of that body is directly proportional to the resultant external force and takes place in the direction in which the force acts. And that's why momentum is given by mass times velocity. See you in our next video. I remain your friend, Augustine Galagash.